Okay, everybody see the screen? Yes, no, maybe. Y'all just not going to talk to me this morning?
Yes, sir.
Okay, thank
We can
you,
see.
one person. I appreciate it. And Mr. King shaking his head. Thank you. The rest of y'all suck. Maybe I should put something else in this green bottle. Maybe that's what I need. All right. Ordered a bunch of pens off Amazon, and they gave me these Sharpies that are retractable, and they don't work very well. I don't like these. I don't. They sent me the wrong ones, but I'll live through it. Okay, 6.2. Now we did cover. Y'all tell me, did we get the standard deviation? Yes or no?
We did.
Okay. I want to make sure. I tell you what, as a precaution, let's make sure that we covered, let's make sure, let me go to the handy dandy overhead and let's make sure that everybody's on the same sheet of music. So let's do a probability distribution with X and P of X. And let's do, and this thing's supposed to autofocus and it's not autofocusing. Is that clear or does it need to be focused some more? And nobody's going to say anything. How do y'all expect me to do stuff if y'all not going to tell me anything? I mean, is that clear?
That's clear.
Thank you. 0, 1, 2, 3, and 4. So this could be 0 out of 4 children. This could be 0 boys, 1 boy, 2 boys, 3 boys, and 4 boys. So that could be, and then again, it could be something else. And we're going to go with 0.2, 0.3, 0.3, 0.1, and 0.1. Okay? All right, now I want you to take a minute, and you can do it in your calculator if you want to. Now, we're going to do it by hand on this paper, so that way, we could do it on the spreadsheet, but everybody, geek out on the spreadsheet, saying, I don't know how to use a spreadsheet. So, and that's not why I'm showing you on the spreadsheet, but I'm going to go ahead and do it on the paper here, so everybody will feel better about that. I'm going to put the formulas over here. The mean is equal to the summation of X times P of X. And the variance is equal to the summation of X squared times P of X minus mu squared. And the standard deviation is equal to the what? How do we always get the standard deviation?
Square root of the variance.
Thank you. Square root of the variance, or the variance raised to the what? 0.5 power. Okay, get to it. I'm going to turn my handy dandy timer on. And if everybody can do this by hand, then you pretty much have 6.1 down. So I'm going to do handy dandy stopwatch and start. Give you another minute. Okay, that's 2 minutes to get everybody started. And I'm going to take my highlighter and I'm going to focus on this guy right here. X times P of X. So that means I've got to take X and I got to multiply it by P of X. This is also called the expected value. So if you have a business type question having to do with money, profit, or gambling type question having to deal with loss or gain or success or failure, then it will be called expected value, but it's the same thing. So I'm going to take a column right here and I'm going to call it X times P of X. Now don't reach for the calculator yet because most of y'all can multiply, this stuff. It's not that difficult. So don't reach for a calculator yet because what's 0 times anything? 0 times any number is what?
0.
1 times any number is that number. 2 times 30 cents is 60 cents. 3 times a dime is what? 30 cents. 4 times a dime is what? Do you know, I actually had somebody ask me, how did you get a dime? How did you get 30 cents? A decimal can be changed into cents by adding a 0 to it. Can you believe somebody had graduated K through 12 and asked me, how did I get a dime out of 0.1? That's scary, people. And what am I going to do to that X times P of X? Let me take my handy dandy, let's see. Let me take my handy dandy green highlighter. What am I going to do with that X times P of X? What does that funky E mean? Capital sigma.
Summation. You're going to add it
Going
up.
to add them all up. Again, I think y'all are okay to add 30 cents and 60 cents. That's 90 cents. 90 cents plus 30 cents is $1.20. $1.20 plus 40 is $1.60. And that's equal to the mean. Okay, that should be kind of, everybody should be like, okay, that's good. And that's my mean. Now, what if it was a business question and asking about insurance or gambling? Then this would be an expected value. It's a positive. So that means that it's a gain or it's a profit or it means success or means that you're going to win. That's a positive. If it was a negative, then it would mean you know, that is not a gain or not successful or not a profit. Question, gripe, complaint. Now, let's go over to this formula here, and let's see what we already have. Well, we've already got mu. We just got mu, so we got that. We got P of X. Let's take an orange marker. We've got P of X. What do we not have? What do we not have for this formula?
X squared.
So we got to make a column called X squared because we don't have it. So I'm just going to go down here and I'm going to rewrite, well, I'm just going to write a column here called X squared. Now again, you don't need to be a rocket scientist. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. And I'm just going to rewrite P of X right here. 0.20, 0.30, 0.30, 0.10, and 0.10. And then I'm going to put a column here called X squared times P of X. Again, you don't need a calculator. 0 times any number is 0. 1 times 30 cents is 30 cents. 4 times 30 cents is $1.20. 9 times a dime is 90 cents. 16 times a dime is $1.60. Now, I'm sorry, if you can't do that after 12 years of school, there is a problem. All right, so $1.60 and $1.20 is $2.80. $2.80 plus 90 cents is $3.70, and $4. I can't believe that. Did I actually get an even $4? Y'all check me on that with your calculator. Say again?
I was just saying I got 4.
Did you get 4? Thank you. Appreciate the interaction. Thank you very much. So that is X squared times P of X, which is right here. X squared times P of X. So the variance is going to equal 4 minus 1.6 squared. And I'm not going to sit here and tell you I can do 1.6 in my head. So I'm going to go to the handy dandy calculator and I'm going to do 4 minus parentheses 1.6 raised to the second power, close parentheses. And 1.44. And the standard deviation is equal to, raise that to the 0.5 power, 1.2. Okay, I need people to tell me if that's what they got.
I got that.
Okay, so let's highlight in green mean, variance, and standard deviation. Now, why did I highlight those green? Because that's your test questions and homework questions in the homework. Now remember, The mean can also be called the expected value. Now, I'm going to say that probably another 5 or 6 times while we're in chapter 6, because I don't want you to be on the homework and get an expected value question and just sit there and stare at it for 15 minutes. All right. The difference between the expected value, sometimes you might get a negative, which means a loss. And that's why it's called expected value. So there's a test question, there's a test question, and there's a test question. Let's do it on the calculator. Let me take another highlighter. Let's take the blue highlighter. And somebody tell me what this looks like right here. This is what's going to be given to you on a test. What does that look like? Looks like X and what? Y, doesn't it? Doesn't it look like X and Y from your pre-algebra days? Yes, Hubert, that's what it looks like. Good. So what you want to do is go to Stat, Edit, and punch those numbers in. 0, 1, 2, 3. Delete, delete. 0.20, or you don't have to put the 0. 0.3, 0.3, 0.1, and 0.1. All right, everybody got that? Now, hit Stat, Calculate, First Variable Statistic. Now, here, see where it says Frequency List? Remember, what is that called? That's called like the frequency, the head count. So you're going to go down there and you're going to put second 2. And what's above the 2? What's in blue above the 2?
L2.
Which is your second column. And hit Calculate. Now, somebody tell me what the calculator gives us. It gives us 2 out of the 3 questions. Somebody tell me what it gives you. Everybody should be saying the same thing, and y'all not saying a word.
The mean.
Thank you. Who was that? My screen didn't light up. Who was that?
It's me, Odessa.
Miss Poor, thank you very much. I appreciate your interaction. I can always rely on the 3 Musketeers, Miss Gravina, Miss Poor, and Mr. King. Y'all notice I'm not relying on the rest of the class. Why is that, the rest of the class? Because y'all suck, that's why. And they say absolutely nothing. Corner office, mops, mop buckets over in the corner of your office. All right, so there's the mean. X bar is equal to 1.6. There's our 1.6 right there. Okay, I'm trying to show you where everything is. All right, what else? Miss Poor said the mean. What else? I told you there's 2 out of the 3. What else they give us? Well, all we got to do is match it up to your answers. Right here. All you got to do is match it up to one of these.
Standard deviation.
Standard deviation. Thank you very much. I tell you, that interaction and communication, isn't it great how it works? Okay. 1.2 is sigma x. That's your standard deviation. So which one do they not give you?
They don't give you variance.
Okay, so somebody tell me how to get the variance from the standard deviation.
Square it.
Square it, not square root it. But we're gonna go through this right quick. I'm gonna go over here. Mean is equal to x bar, which is equal to 1.6. That's from the calculator. And then the standard deviation, or sigma, they call it sigma x, is equal to 1.2. Therefore, the variance is equal to the standard deviation raised to the second power, which is equal to 1.2 raised to the second power, which is equal to what? Somebody take 1.2 and raise it to the second power, please.
1.44.
Now, I wanted everybody to do that. I know it's right here. We got the answer. But I wanted everybody to put it in their calculator so they could actually see how to get the variance from the standard deviation. Okay? Which we went over that back in chapter 3. But I wanted everybody to remember it. So you can actually get 2 out of the 3 from your calculator. Everybody got that? I don't remember if I showed y'all the calculator. Did I show y'all the calculator the other day? Well, now I did. So now anything else we do, well, I'll do on the spreadsheet now that I did it by hand for some of y'all that's scared of the spreadsheet. There it is. This is how you do it. If you don't use a spreadsheet and you don't use your calculator, this is how you do it on, paper. Okay? All right, now 6.2. 6.2, we're going to be dealing with questions that basically, let me give you an example. You flip a coin 500 times. And the probability of tails ends up to be 0.63. So in other words, for every 100 times you flip a coin, 63 times it comes up a tail. And that's what it did for those 500 times. It came up 0.63. What is the probability of tails if you flip the coin 50 more times? All right, that's the type of question you're going to see, and the added feature is here. If you flip a coin 50 more times, what is the probability of tails for those 50 times? All right, now this is a kind of a basic of the basic questions, but I want you to see, what have I always taught you about n? N is always the biggest what?
Number.
So which one is the biggest number? You got 3 numbers here.
500.
Which one's the biggest number?
500.
P is always your probability or your percent. So which one do you think your P is?
0.63.
Okay, Mr. King, you've answered 2 questions. You're not going to be the only one that communicates. Ms. Poor has communicated. Ms. Gravina. So that means you need to communicate. All right, now, if I've already got 2 out of the 3 numbers, then what do you think X is going to be? 50. Now, in 6.2, in the first point, in 6.2, we're going to be dealing with NPX and NPQ. So write that down. In 6.2, we are going to be working with NPX. That's the first part of 6.2. And then later, we're going to be working with NPQ. So I just want to put that later in 6.2. The second part of 6.2, we're going to be dealing with NPQ, which these questions right here, just plug and chug. You're going to have a formula. The mean is equal to NP, and the standard deviation, the variance, is equal to NPQ, and then the standard deviation is equal to the square root of the variance. All right, so that's later in 6.2. In the first part of 6.2, when we're dealing with NPX, you're going to be using your calculator, and you're going to be using binomial PDF and binomial CDF. Okay, and a lot of these problems, you're going to be dealing with equals to these guys and these guys. All right, so you're going to be looking at the signs, or the inequalities, or the equalities. All right, so the first part of 6.2, you're going to be using your calculator, because I don't let you use the formula because it's too complicated. Not too complicated, it's too tedious. I mean, it's just a lot of extra work for nothing. So we're going to be using the calculator to do this. All right, here, you don't need the calculator to just multiply 3 numbers, and those numbers are not going to be big. So we're going to be dealing in the second part of 6.2, we're dealing with these formulas. Okay, and this type of question right here is the first part where you actually put in. I'm going to show you what the calculator looks like. And you're going to type in, let me clear everything. Hold on. Clear. You're going to type in second bars and go down. There they are. Write those down, A and B. Binomial PDF, which means exact. Exact. Meaning the equal sign. The C for CDF means cumulative, which means the inequalities. So you got binomial PDF and binomial CDF. And the way that you use it always asks for NPX in that order. So I hit enter, and I would type in 500.63 and 50. So the probability, and if you got an older calculator, you're not going to have these 3 things. It's going to look like this. That's how you're going to type it in an older calculator. You're going to do binomial PDF and then parentheses and then 500, comma, 0.63, comma, and 0.5, close parentheses. Or 50, I'm sorry, not 0.5, 50, comma, 50. And the probability for tails on those last 50 tosses are That's not right. Did I type in something wrong? Let me do that again. Binomial. I know I just didn't pick the numbers and hit 0. I know I didn't do that. Let me do that again. Second bars. Let me do CDF and see if it does it. It doesn't matter since it's equals. 500.63 and 50. Wow. I won't do that in another million years. Okay. I actually picked 3 numbers that would give me a 0 probability. I'll never do that in a million years. Sorry about that. But anyway, there's a 0 probability that you're going to hit tails. That's not right. But anyway, I must have picked bad numbers. So let's look at the slides. That way we can do a good example and not get 0 probability. Here is the test for a binomial probability, PDF or PD or CDF. And write these down. The experiment has to be a fixed number of times. Write that down. Like we said, 500 flips. Has to be a fixed number. You can't say, oh, well, 500 here, 520 here, 540 here. Has to be a fixed number, 500. The trials are independent. What does independent mean? Back from chapter 5 of the multiplicative law, what does independent mean? Okay, I'm asking.
They don't affect one another.
Exactly. In other words, remember the marble bag? Independent is putting the marble back in the bag after you pick it. After you write it down, you put it back in the bag, meaning that the statistics for the next draw does not change. What would that be? A good example of this would be a die or a what? A coin. If you flip a coin and you get tails, does that mean that tails is erased for the next flip? No. You still got heads or tails, and you flip it again, you're going to get heads or tails again. So they're independent. What about a vote or a body? No. You can't do a vote or a body because once you vote, well, I mean, let's not use vote. I'm not going to, after the last election, I'm not going to use that. Let's use bodies, okay? If you are on a committee, can you be on another committee with that same setup? No. You can only be in one place at what? One time. You see what I'm saying? So there are some questions that you can't do because the trials are not independent or dependent, which means a body or a vote or something like that. For each trial, there are 2 mutually exclusive choices or outcomes. What about a die, Hubert? There's 6 numbers on a die. Yes, but what's the probability of one number? What's the complement of the probability of 6? What's the complement on a die? The probability of 6. Not rolling, the probability of 6. That's the complement. You don't say, oh, well, that means probability of 1, 2, 3, 4, 5. No, you either roll a 6 or you what? You don't roll a 6. Okay? So, and the tails and heads, that's two mutually exclusive. So you got to think of a lot in part, and put number 3, put beside the parentheses or put beside the period, put complement. Because a lot of times you're going to be using the complement to test for number 3. And then number 4, the probability of success is fixed for each trial of the experiment. In other words, heads or tails, you're not going to get some third answer from heads or tails. You're going to get heads or tails, or you're going to get 6 or not 6. There's not going to be anything come up and say, oh, well, the coin landed on its edge. That's not going to happen. All right. And let's see. That's just a reproduction of what we just said. Let me find. Okay, here's an example. A player rolls a pair of die 10 times. There's your fixed number of trials. The number of X of 7s. Okay, you're either going to have 7 or you're not going to have 7. There's your two independent, or there's your two exclusive outcomes. You're either going to roll a 7 or you're not going to roll a 7. Everybody with me? The die. Does the numbers change on the die each time you roll them? No. They're always 1 through 6. So that's not going to change. So this would be a binomial experiment. And that's a test question. Is the following a binomial experiment? And you read it, and then you say yes or no. Next one. All right, now I want you to write this one down because I want you to be able to know what is the difference between a binomial experiment and a non-binomial experiment. So go ahead and write this down. And you got numbers in there, but why isn't it a binomial experiment? And it has it right there, not a fixed number, but I want you to tell me what that means. Why isn't it a fixed number? Go ahead and read it and write it down. And you don't have to write it word for word. 11 airlines on a number of percentage, 84%, blah, blah, blah. You don't have to write it word for word. But go ahead and write it. Give you about 30 seconds to write that down. Miss Poor, Odessa is a town in Texas. Did you know that?
Yes, sir. I did. I used
I
to
only
get
know
called
that because one of my favorite movies is Tin Cup, and they talk about Odessa, Texas. That's the only reason I know that.
Yes, sir.
Anybody ever seen Tin Cup? Oh yeah, that's right. It's not a cartoon or a comic book, so y'all haven't seen it. It's actually a very good movie, but
What's it about?
it's about this golfer that could have been a great golfer, but he always went for it instead of being conservative. And you have to know about the game of golf to understand that. And instead of being a PGA golf champion, he runs a driving range in Salome, Texas, which is near Odessa. And he falls in love with, what's her name? Oh gosh, I can't think of her name right now. Oh gosh, very, very pretty actress. I can't remember her name right now, but he falls in love with her, and he wants to prove himself by winning the U.S. Open. And this a good movie. It's called Tin Cup, Tincup. What's his name? Kevin Costner is the golfer. I can't believe y'all haven't seen that movie. It's sad. It's your parents' fault. But I guarantee you, y'all seen all the Marvel movies, and you've seen all the cartoon movies from Disney, and you've seen all those, haven't you? Yeah. All right. Somebody tell me why there's not a fixed number of trials. I mean, you got 11 largest airlines. You got P. You got X is 10. Why isn't a fixed number of trials? Anybody want to take a stab at it?
It says until she finds 10. So that means that they're just going to do it until they find the number that they need.
Yeah, that's a pretty good explanation. That's pretty good. Thank you. You stole my thunder. Thanks a lot. But anyway, that's pretty much it. You just gotta, once you start reading some of these, you'll start seeing it. I mean, but that's pretty much it. Let's go to the next one. And this next one's going to be a good example. You don't have to write this one down. This is not a binomial. I didn't know they had an extra one. Yeah, okay, it's not a binomial. Okay, why? Okay, this is talking about bodies. Remember, bodies and votes. You can't be in two places at one time. It says in a class of 30 students, 55 are female, 55% are female. The instructor randomly selects 4 students. The number X of females selected is recorded. Well, you cannot do this without, in other words, if I pick 4 students, what's left of the pool?
26.
And then what if I pick 4 more students, what's left of the pool?
22.
So each time I pick 4 students, what happens to the math or the probability for the next one? It changes. So that's not this dependent. Okay? So that's 3 examples of what we're talking about here. And I'm going to show you right now how you come up with a probability distribution. They use airlines. I'm going to use babies. Okay, now remember I told y'all to write down or put on the index card, which I know two or three of you did this. You remember the index card that I told you to keep the kids, you know, the 3 sets of kids? Boy, boy, boy. Girl, girl, girl. Remember that? And you have boy, girl, 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 boy, girl, girl, boy, boy. I can't think of all of them right now. But you remember that I told you to put that on the index card? Everybody remember that? And 2 of you did it. So we're gonna make a binomial, a probability distribution using 3 children with the probability of a boy being equal to 0.47. Well, when they do that when they do this in a problem, what should you instantly say when you read the probability of a boy is 0.47? What should instantly come to your mind if I say the probability of a boy is 0.47? Well, what's the opposite of a boy?
Girl.
A girl. Therefore, the probability of a girl is what?
0.53.
Thank you. Appreciate y'all's interaction. Appreciate the rest of the class interacting with me. Thank you. Hope y'all are all going to be librarians. Now the question gives us this. Okay, you have to come up with this. Create a probability distribution using 3 children with probability of boys being 0.47. So I'm going to write down X event, and X event is, I can start with boy, 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 which means 0 girls, 1 girl, 2 girls, and 3 girls. And then the probability of the event, 0 girls means boy, 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 which means 0.47 raised to the 3rd power. So you take your handy dandy calculator and you do 0.47 to the 3rd power. My headache's gone. 0.10, I'm going to say 0.10. All right, so let's go to girls. 1 girl. Well, that would be boy or girl, boy, 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 girl, boy, and boy, boy, girl, which is equal to, well, that's going to be 0.3. There's 3 instances here, so that's 3 times 0.47 to the 2nd power times 0.53, because 0.53 times 0.47 times 0.47, 0.47 times 0.53 times 0.47, oops, I'm sorry. There we go. And 0.47 times 0.47 times 0.53. So we got 3 of those, so it'd be 3 times those parentheses. So I'm going to go 3, take my calculator, and I'm going to clear this, and I'm going to clear this, and that's going to be 3 times, parentheses, 0.47 to the 3rd power, oops, times 0.53. Oops. And close parentheses. 0.17. And then girl, girl, boy, girl, boy, girl, and boy, girl, girl. That's equal to 3 times 0.53 to the 2nd power times 0.47. So that's going to be 3, clear, clear, and that's going to be 3 times, parentheses, 0.53 raised to the 2nd power times 0.47. And that's going to come out to be 0.40. and show you where I'm at. There's where I'm at right there. And now what will 3 girls be? Well, that'd be girl, 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 which is equal to 0.53 raised to the 3rd power. So 0.53 raised to the 3rd power. 0.15. Okay? And that's how you make a probability distribution. Now, I'm just showing you this. I'm not going to ask you to do this on a test, but that's how you do a probability distribution. Okay? All right. Now, I told you in the first part of 6.2, we're going to be using these guys right here. We're going to be using these. Now, when you're talking about these, this one's easy. This one means exactly. All right, so you don't have to know too much about this one because it means is, it means total, sum, product, no, not sum and product, that's plus and multiplication. I'm sorry, but when you see these words, exactly, is, total, that means equals, and most of y'all know that. But what do these words mean? What words mean these guys? Well, that's where we're going to get into the slide here that talks about that. And I want you to write this one down because some of y'all really suck at this. So go ahead and write that down. So this one means at least. This one means at most or equal to. At most or equal to. This one is greater than. And less than. Now, the one y'all really suck at is the one that goes at most or at least. That's the one that y'all really suck at. I'm just letting y'all know. I'm not talking to just you students in this class. I'm talking, when I say y'all, I mean students in general. Students in general suck at fractions, word problems, graphing, and at most and at least. So it's kind of like, you know, when you're facing an addiction, what's the first thing that you need to do? You need to acknowledge that you're addicted. Well, just like math, you need to acknowledge what you suck at. And I'm just helping you out. Does everybody appreciate me helping you out by telling you you suck at certain things? Good. Yeah, it kind of helps to know what you suck at. All right. Now, I'm just going to remind you with a number line. I'm going to remind you what at most and at least means, because it's very important that you understand that. At most, that's positive infinity, that's negative infinity. So at most means 0, 1, 2, oops, 2, 3, 4, 5. Now remember, in chapter 6, we're not talking about decimals, are we? We're talking about households. We're talking about bodies. We're talking about games. We're talking about boys and girls. So you can't have 1.5 boys. You can't have 5.5 households. You can only deal with what? Integers. So remind yourself that we're talking about integers. And I don't know if I spelled that right, because I always want to put an E in there. I hope that's right. Integers. And integers means that you're only dealing with the whole numbers. So at most 4 means the biggest number is 4. The biggest number is 4. So that means well, Hubert, why don't you have negatives? Can you have -3 girls? Can you have -500 households? No. So when you're talking about surveys and you're talking about, boards or committees, or you're talking about flips of coins, you can't negative flip a coin. Okay? So you can't, negatives, we're going to put this in red. When you're talking about these things, negatives, there's no negatives, there's no decimals, and there's no fractions. Okay, so there's not that, not that, and not that. So the only thing left is what? The only thing left in green is whole numbers. Positive whole numbers. And at most means that your largest number is 4. So if at most means the largest number is 4, then what does at least mean? The lowest number is, we'll use 3. So 0, 1, 2, 3, 4, 5. So that would mean 3, 4, and 5. So that's why people suck at these two, because they don't think about what it's actually saying. At most 4. So that means that the highest number is 4. So in this case of 5 households, that means 4 and what? Below. In this case of 5 households, 3, 4, and 5 is the only ones we can deal with, because it says at least 3. So you got to know these two. If you don't understand these, you need to sit there and stare at it and figure it out. This is not a problem with y'all, because y'all know less than. If I say less than 3, then that would be what? 2, 1, 0. If I said greater than 2, that would be 3, 4, 5. So y'all get these. Y'all just suck at these. And now that everybody knows what they suck at, let's move on. Now, where is your formula? Okay, I'm giving you this formula right here, not for you to do, because we're going to do it in the calculator. So I want you to write that formula down. It says that if I want to find the probability of an event happening with the binomial distribution, I do n combination x times p to the x power times q to the n minus x power, where all numbers are what? Whole numbers and what? Positive. That's what that means. You don't have to write that. Just say out to the side, all numbers are positive integers. You can say that. So in other words, you're going to put in a bunch of whole numbers right here. But we're not going to do this formula, but that's the formula. N combination x times p to the x power. 1 minus p is the same thing as q. Q to the n minus x power. That's the formula that we're going to be using, and I'm going to write it down right here. The probability of an event happening with a binomial probability is equal to n combination x times p to the x power times q to the n minus x power. And this is used for positive integers. Now, I just wrote that down right here. And this is when we use NPX. And we use that with second bars. And what numbers was it? Was it A and B? A and B. And I think A is PDF, which is equal to, and cumulative is cumulative CDF, which means less than, greater than, less than or equal to, greater than or equal to. Okay, so I'm not going to ask you to, let me put that in red so you don't think it's part of the formula. I'm not going to ask you to learn this formula, okay? Because it's a lot of extra work when you can just do it in your calculator. So let's look at one. And there it is. And let me put it on the, it's supposed to let you, I don't know why it's putting the answer on there. But anyway, according to Experian Automotive, 35% of all car owning households have 3 or more cars. In a random sample of 20 car owning households, what is the probability that exactly 5 have 3 or more cars? Okay, so P is point, let's write this down. I'm going to write it down and you write it down also. %35 of all car owning households have 3 or more cars. In a random sample of 20 car owning households, what is the probability of exactly 5 have 3 or more? So N is equal to 20, P is equal to 0.35, and X is equal to 5. Okay, 35% of all car-owning households have 3 or more cars. In a random sample of 20 car households, what is the probability of exactly 5 having 3 or more? So we go to our handy dandy PDF and we do second, bars, binomial PDF, which means exact, and 20.35, and what, 5? And paste. And if you have an older calculator, that's what you type into the parentheses, 20, comma, 0.35, comma, and 5, and hit enter. 0.1272. So you got a 12 or 13% chance that the 20 households is going to be 3 or more cars. Oh, I'm sorry. The probability that 5 of the 20 is going to have 3 or more cars. That's a 13% chance. All right, now let's look at the next question. All right, here's the next one. And this is where you're going to see your inequalities come in. In a random sample, blah, 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 what is the probability that less than 4? Now, I'm going to write this down, and I suggest you write it down because you're going to have to draw the number line so you can understand what this one is asking. So we still got x is equal to 20. And we've got p is equal to 0.35. And I'm going to put x is equal to parentheses because it says less than 4. Okay, so I'm going to take my handy dandy calculator, my handy dandy whiteboard, and we're going to draw a number line. Well, I don't have to do positive infinity because this is 20 and this is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... all the way up to 20. Okay, I want you to tell me what numbers on the number line are less than 4. That means I want y'all to talk. I want y'all to speak.
1, 2, and 3.
Say again.
1, 2, and 3.
And 0.
Oh, and 0.
Remember, does 0 households make sense? Yes. How many households in your neighborhood doesn't have running water and toilets? Somebody tell me how many. Somebody lives in a subdivision. I can't tell you that because I don't live in a subdivision. Somebody lives in a subdivision or an apartment. Tell me how many apartments doesn't have running water and toilets. Everybody's supposed to say 0. I'm trying to show you that you can have 0 households. Now, why did I not do 4? Because it says what? Next semester, everybody's going to have their video on and they're going to talk. Next semester. Thanks to this semester, I'm going to force videos. It's mandatory. If you don't have your video on, you're counted absent. I'm tired of this. This is ridiculous. All right. So less than 4. So how do you do less than 4? Well, you could do NP0 plus NP1 plus NP2 plus NP3 and do that each time on your calculator. Second vars 20.350 and write that number down. Then second vars 20.351 and write that number down. And then second vars 20.35 and 2, write that number down. And second vars 20.35 and 3 and write that number down, and then there's your answer. Now that's the long way to do it. But since you're doing cumulative, you can do CDF, and it will add all these up to that number. CDF will add all those numbers up to 3. So let's go to CDF. Now I want somebody, let's go ahead and let's do it both ways. Let's go ahead and I'm going to take my handy dandy calculator. And I'm going to show you a trick I learned in the war. Hit second entry, and all you got to do is change that to a 0. And that's negative 0.00018. 0.00018. And I'm writing these down as I go along. Okay? And second, well, I'll tell you what I'm going to do. I'm going to stow alpha A. Okay, so that's gone. Now I'm going to hit second entry, second, well, wait a minute, second entry. There we go. And I'm going to change that to a 1. And I'm going to put 0.0020, 0.0020. And I'm going to stow, I'm going to the stow alpha B. And now I'm going to hit second entry, second entry. I'm going to change that to a 2. And that's going to be 0.00, well, it looks like 0.010. Yeah. Wouldn't y'all say that's it? 0.0100. Y'all settle down, please. Stow alpha C. And second entry, and 3. And that's going to be 0.0323. And I'm going to stow alpha D. And now I'm going to clear. I guarantee you somebody went through the last 4 years of high school and didn't know you could store stuff. I bet you $1 somebody in here is like that. Alpha A plus alpha B plus alpha C plus alpha D. I got 0.0444. Okay, so let's do it the short way. Let's go with second vars binomial CDF, and we've got 20.35 or 0.35, yes, and less than 4 would be 3. Well, Hubert, what about 3.5? We don't have 3.5 households. You don't have decimals and fractions. So the only number less than 4 is 3, 2, 1, 0. So that's CDF means that you go from 0 to 3 and paste. And if you got an older calculator, that's what you would type in, 20, comma, 0.35, comma, 3. But you got to make sure you're doing cumulative CDF. I got 0.0444. It's a miracle. Look there. It's a miracle. Got the same thing and didn't have to do half the work. So some of y'all really enjoy that. That's why you're going to be in the janitor's closet. And if you do the calculator, binomial CDF does 0 through 3, and it got the same thing, 0.0444. And everybody feels good about themselves, right? Do y'all realize we are almost out of class, out of time? We are out of time. Okay, I want to show you one last thing right quick. I want you to write these down. Write this problem down right here. Because they're asking, now what is the difference in this question and the previous question? The previous question is asking for probability. What is this asking for? What is this one asking for?
Mean and standard deviation.
That's the difference between the two questions. So you got to be able to find the mean and the standard deviation. This is just plug and chug. So I want you to write that down. Write this question down as we finish. Write this question down and write down the plug and chug right there, because most of y'all should be able to determine the mean and the standard deviation. Oh, I'm not going to use my calculator. I'm going to use NP and NPQ. So just write that down, and when you finished, you can pretty much leave because I've already called the roll. And that means y'all can do 6.1 and 6.2 homework, and you should be working on that all weekend. And Tuesday we'll be moving into chapter 7. Remember, this is a short section. This is a short unit. There's only like 4 sections. So everybody should be able to knock these 4 sections out, these 2 sections this weekend, and send me questions for the 2 or 3 that actually does the homework. You know, you should be able to send me questions for Tuesday. Okay. All right. Who's got questions? You can finish writing that down. I'm going to leave it up until everybody leaves. The rest of y'all have a good weekend, and I'll see y'all Tuesday. Yeah. See you later. Bye. Yeah, bye. Have a good weekend.
Bye.
Bye. Have a good
See ya.
weekend.
Bye-bye.